Hello dear students, welcome back to the online CET classes. In this class, I am going to explain the CET questions on the topic waves. Before going to solve the multiple choice questions, within 10 to 15 minutes, just I revise the some important problems on this topic. Here, the first concept is the different types of waves. Waves can be divided into so many types. Firstly, mechanical waves and electromagnetic waves. Waves, it is nothing but the disturbance created in the medium is called waves. Waves can be divided into two types, electromagnetic waves and mechanical waves. Electromagnetic waves and mechanical waves. The waves which are requires a medium for their propagation are called mechanical waves, and which does not requires a medium for their propagation are called electromagnetic waves, or they are also called non-mechanical waves. The waves which requires a medium for their propagation are called mechanical waves, which do not requires any medium for their propagation, that is called electromagnetic waves. Again, the mechanical waves are classified into two types. Here, all of you have studied this concept in your higher education. But according to your syllabus, the mechanical waves can be divided into two types, the progressive waves and stationary waves. Progressive waves and stationary waves. Again, that progressive wave can be divided into two types, longitudinal waves and transverse waves. The waves which are parallel to the propagation of the wave, they are called longitudinal waves. Which are perpendicular to the direction of their propagation, they are called transverse waves. All these are the basic concept already all of you are studying in your first PUC topic. Here, the first important concept in this topic is that is displacement relation for a progressive wave. Displacement relation for a progressive wave. A wave which proceeds in the medium without being reflected, that is called progressive wave. Wave which proceeds in the medium. A wave which requires a medium for their propagation are called mechanical waves. Wave which produce in the medium without being reflected is called progressive wave. This may be longitudinal or transverse. And plain progressive harmonic wave, if the particles of the medium vibrates about its mean position, and wave is said to be plane progressive, or it is also called harmonic wave. Harmonic means it is nothing but integral multiple of the waves. Wave which proceeds in the medium without the reflection, then it is called progressive wave. If it vibrates about the mean position, then it is said to be harmonic wave. Here, in harmonic progressive wave, they are having the same amplitude with the same frequency, same amplitude, but the phase of oscillation changes from one particle to another particle. Here, this is called transverse waves. This is called transverse waves. Wavelength means here the distance between two crust or two trough in the wave is called wavelength. They are always perpendicular to the direction of the wave propagation. Then it is called transverse waves. Here the amplitude is constant throughout the propagation. Wavelength, it is mathematically denoted by the symbol lambda. It requires a medium for their propagation. Here the wave starts from the origin and travel along the positive x-axis with the speed v. In this diagram, the wave starts from the origin and travel along the positive x-axis with the speed v. When time t is equal to 0, the particle is at the origin initially, passing through its mean position. The initial phase of the particle is 0. But the displacement of the particle at any point O at any instant, that is y equal to a sine omega into t. The displacement of the particle or the displacement of the simple harmonic motion, you know the formula, y equal to a sine omega t. A is the amplitude, omega is the angular velocity with respect to time t. Therefore, where a is the amplitude, omega is the angular frequency with respect to time, Hence, now we consider another particle P on the x-axis at the distance x from O. Consider a particle P on the x-axis at a distance x from P, and this is amplitude. Amplitude means the maximum displacement of the particle from its mean position is called amplitude. The disturbance starting from origin, it will reach the point P and starts vibration x divided by v seconds. X divided by v seconds later the particle at O. X divided by v. A is the amplitude, and this starts vibrating from its origin, the point P, and it reaches to it vibrating x divided by v seconds later than the particle at O. Therefore, lambda is the wavelength. Lambda is the wavelength. Now, the displacement of that particle at any point P with the instant t, that can be obtained by replacing t minus x divided by v. Therefore, the displacement of the simple harmonic motion. In general, the displacement of the simple harmonic motion is, that is, y equal to a sine omega into t. Here we write, instead of t, y is equal to a sine omega into t minus x divided by v. T minus x divided by v. Therefore, now you get the new equation when you are multiplying omega with time t and with x divided by v. We get this equation, y is equal to x comma t is equal to a sine omega t minus omega x divided by v. Therefore, omega divided by v is equal to 2 phi n divided by v equal to 2 pi by lambda. This is called propagation constant. K is equal to omega divided by v, or 2 phi by omega, or 2 phi n divided by v. This is very important term. Remember this formula. K is equal to omega divided by v, or it is equal to 2 phi n divided by v, or it is equal to 2 phi divided by lambda. This is called proportionality constant. Therefore, we get the equation y equal to x comma t. Y is equal to x comma t. This equation alli barta idini. Y equal to x comma t equal to a sine omega t minus omega divided by v. Omega divided by v, this is equal to k. K into x. Therefore, this equation represents the harmonic wave traveling along the positive direction of x-axis, or y equal to x comma t a sine kx minus omega t along positive x-axis or along the negative x-axis. Therefore, omega is equal to 2 pi by t. Instead of omega, ಎಲ್ಲಿ omega ಇರುತ್ತೆ ಅಲ್ಲಿ 2 pi by t ವ್ಯಾಲ್ಯೂವನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಾಗ ಈ ಈಕ್ವೇಷನ್ ಬರುತ್ತೆ, y equal to x comma t is equal to a sine 2 pi by t into t minus 2 pi by lambda into x. Therefore, a sine, take the common value outside, 2 phi, y equal to a sine 2 phi small t divided by capital T minus x divided by lambda, or a sine 2 pi by t is equal to t minus x by lambda into t. But lambda divided by t is equal to, that is speed, velocity. Therefore, a equal to y equal to a sine 2 phi by t, t minus x divided by t. Again, you get the same equation. This is about the displacement equation. If the initial phase of the particle at 0 with the phase angle phi naught, then the wave equation will be, these are the different kinds of the wave equation. ನಿಮಗೆ ಯಾವ ರೀತಿ ಟರ್ಮ್ ಬೇಕೋ ಆ ಇಕ್ವೇಷನ್ ಅನ್ನು ನಾವು ಮಾಡಿಫೈ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಬಟ್ ಇನ್ ಜನರಲ್ ಇಕ್ವೇಷನ್ y equal to a sin omega t minus phi or plus phi along the positive x-axis and along the negative x-axis. Omega t minus plus phi or minus kx plus phi naught. Our harmonic wave, it is traveling along the negative x direction. Again, we get a sin omega t plus kx minus kx, that is along the positive x direction, and omega t plus kx, that is along the negative x direction. ಇವೆಲ್ಲ ಫಾರ್ಮುಲಾಗಳನ್ನ ನೀವು ಥಿಯರಿಯಲ್ಲಿ ಇನ್ ಡಿಟೇಲ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಿ. ಇಲ್ಲಿ ಜಸ್ಟ್ ನಾನು ರಿವೈಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಿಮಗೆ ಯಾವ ರೀತಿ ಬರುತ್ತಾ ಅಂತ ಹೇಳಿ. ನಾವು ವಾಟ್ ಈಸ್ ಆಂಪ್ಲಿಟ್ಯೂಡ್? ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫ್ ಎನಿ ಪಾರ್ಟಿಕಲ್ ಆನ್ ದ ವೇವ್ ಫ್ರಮ್ ಇಟ್ಸ್ ಮೀನ್ ಪೊಸಿಷನ್ ಆನ್ ಐದರ್ ಡೈರೆಕ್ಷನ್, then it is called amplitude. And the second condition or the terms connected with wave, that is called phase or phase angle. It is mathematically denoted by the symbol phi. It means the wave quantity that gives the complete information of the wave at any time and at any position, that is called phase. It is mathematically denoted by the symbol phi equal to omega t minus kx plus phi naught, that is called initial phase. Phi naught, that is called initial phase. If the wave is periodic in both the space and time, when x equal to 0, time t is also 0, therefore then phase is equal to initial phase. When x equal to 0, time t equal to 0, in that condition phase is equal to initial phase. Therefore wavelength means it is the distance covered by the particle or distance covered by the wave during the time in which the particle of the medium it completes one vibration about its mean position. Complete one vibration about its mean position. Therefore, it is the distance between the two particles of the medium which are vibrating in the same phase. Vibrating in the same phase. Then the angular wave number or propagation constant k. The quantity 2 phi by lambda, that is called angular wave number, and it represents the phase change per unit path difference. Its unit is radian per meter. Its unit is radian per meter, or k is equal to 2 phi by lambda. Time period means the time in which a particle of the medium it completes one vibration about its mean position. Then it is called time period. Frequency means the number of waves produced per unit in a given medium. Then it is called frequency. F equal to 1 divided by t, or n equal to 1 divided by t. Or it is also, you can write this equation in the form omega equal to omega divided by 2 phi. T is equal to 2 pi by omega, or 1 by t equal to omega divided by 2 phi. The SI unit of frequency is per second or hertz. Per second or hertz. Angular frequency, it is mathematically denoted by the symbol omega. The rate of change of phase with respect to time, then it is called angular frequency. For one complete time period, the phase change is, that is 2 by t, or omega equal to 2 pi by divided by t, or 1 by t equal to frequency. Then you can write this equation omega equal to 2 phi into n. Then the SI unit for the angular frequency is radian per second. And wave velocity means it is the ratio of angular frequency to the propagation constant. P is equal to omega divided by k, or lambda into 1 divided by t. Therefore, phi is equal to frequency into lambda. This is the relation between wave velocity, wave frequency and wavelength. ಈ ಫಾರ್ಮುಲಾವನ್ನು ನೀವು ಸ್ಟಡಿ ಮಾಡಿದಿರಿ. ದ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ವೇವ್ ವೆಲಾಸಿಟಿ, ವೇವ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆ್ಯಂಡ್ ವೇವ್ ಲೆಂತ್. V is equal to n into lambda, or it is meter per second. Now, the relation between phase difference and path difference. Suppose if I consider a 2 points at the positions x1 and x2 on the wave at a given instant. At a given instant, here phase is mathematically denoted by the symbol phi. Here consider the 2 points at x1 and x2. Phi 1 equal to omega t minus kx1, phi 2 equal to omega 2 minus kx2. But phi 1 minus phi 2 is, that is k into x2 minus x1. Therefore, x2 minus x1 means the change in the position of that wave. Delta phi equal to k equal to 2 pi by lambda into delta x. Therefore, delta x is equal to lambda, and delta phi is equal to 2 phi. If the path difference it corresponding to the phase change of the 2 phi radians. Therefore, delta phi equal to 2 pi by t instead of delta x. Here you write delta into t. ಎಲ್ಲ ಫಾರ್ಮುಲಾಗಳನ್ನು ನೀವು ಸ್ಟಡಿ ಮಾಡಿಬಿಟ್ಟಿರ್ತೀವಿ. ನಾನು ಜಸ್ಟ್ ರಿವೈಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ ಫಾಸ್ಟ್ ಆಗಿ. Delta phi equal to 2 phi divided by t into delta t. Here, delta t, it is the time difference. From using all these simple problems, ನಿಮಗೆ ಬರ್ತಕ್ಕಂಥದ್ದು ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ ಇಲ್ಲಿ CET ಮತ್ತು ನೀಟು ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ. ಹೌದಾ? ಈ ಫಾರ್ಮುಲಾವನ್ನು ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. ಅಂದಾಗ ಮಾತ್ರ ಈಸಿಯಾಗಿ ನೀವು ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಇದನ್ನು ಥಿಯರಿಯಲ್ಲಿ ಇನ್ ಡೀಟೇಲ್ ಆಗಿ ನೀವು ಕಲ್ತಿರ್ತೀರಿ. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಇಲ್ಲಿ ಇನ್ ಡೀಟೇಲ್ ಆಗಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಕ್ಕೆ ಹೋಗಿಲ್ಲ. ನೌ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ದ ನೆಕ್ಸ್ಟ್ part of your topic. Here directly I am going to the questions. Applied multiple choice questions. ನಿಮ್ಮಲ್ಲಿ ಬೇಸಿಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಇರ್ತಾವೆ. ಅದಾದ ನಂತರ ಫಾಸ್ಟ್ ಕಾಂಪಿಟೇಟಿವ್ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸ್ and applied multiple choice questions. This is the third part in your material. ನೀವು applied multiple choice questions ಅನ್ನು ನಿಮ್ಮ ಮಟೀರಿಯಲ್ ಓಪನ್ ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ ಅದರಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಫಸ್ಟ್ ಕ್ವಶನ್ ಇದೆ ಇಲ್ಲಿ. ಅದರಲ್ಲಿ ಬರ್ತಕ್ಕಂಥದ್ದು ಫಸ್ಟ್ ಕ್ವಶನ್. A progressive sound wave of frequency. Progressive sound wave of frequency 500 Hz. A progressive sound wave of frequency 500 Hz is traveling through air with the speed of 350 meter per second. With the speed of 350 meter per second. A compression maximum appears at the place at a given instant. The minimum time interval after which the rarefaction maximum occurs at the same point. ಇಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂಥ ಕ್ವಶನ್, this question is based on the progressive wave. Here, a progressive sound wave of a frequency. Frequency, it is mathematically denoted by the symbol f or n equal to 500 Hz. Frequency is 500 Hz. Is traveling through air because progressive wave which requires a medium for their propagation with the speed of v is equal to 350 meter per second. A compression maximum appears at a place at a given instant. Minimum time interval after which the rarefaction maximum occurs at the same point. Same point alli barಬೇಕಾಗಿದೆ rarefaction. You know the formula. T is equal to f equal to 1 by t. Frequency f equal to 1 by t. T is equal to ಏನಾಗತ್ತ formula 1 divided by f. F equal to ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು already 500 Hz. When it compress, the minimum time interval after which the rarefaction maximum occurs at the same point. ಅದೇ ಪಾಯಿಂಟಿಗೆ ಬರಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಅವಾಗ ಏನು ಮಾಡ್ತೀವಿ ನಾವು, that is divided by 2. T is equal to capital T divided by 2. Therefore, that is 1 divided by 1000 second. 1 divided by 1000 second. Option D is the right answer for this question. And the next question is, the speed of the longitudinal wave in a wire is. The speed of the longitudinal wave in the wire is 100 times the speed of transverse wave. And if Young's modulus of the wire material is 1 into 10 to the power of 11 Newton meter square, then the stress in the wire is. Here, the speed of the longitudinal wave. The speed of the longitudinal means that is V longitudinal. The speed of the longitudinal wave in a wire 100 times the speed of the transverse wave. V longitudinal is equal to 100 times of the speed of the transverse wave. 100 times of the speed of the transverse wave. If Young's modulus of the material of the wire is 1 into 10 to the power of 11 Newton meter square ಅಂತ ಇದೆ. If V is equal to, ಅವಾಗ ಏನಾಗತ್ತ ಫಾರ್ಮುಲಾ, Young's modulus divided by density D. Root of Y divided by D is equal to 100 times of stress for transverse waves. This is for longitudinal waves, and for transverse waves this is stress divided by Young's modulus of the wire. Stress divided by D. Here this is the speed of the longitudinal wave formula, and this is the speed of the transverse waves formula. Y root of Y divided by D equal to 100 into root of stress divided by D. Small d and small d ಎರಡು ವ್ಯಾಲ್ಯೂವನ್ನು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದಾಗ root of Young's modulus. Young's modulus of the wire of the material value ಎಷ್ಟಿದೆ, 1 into 10 to the power of 11. 1 into 10 to the power of 11 is equal to 100. Root of stress. 100 root of stress. ಯಾವ ವ್ಯಾಲ್ಯೂವನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಂತ ಯಾರು, ಸ್ಟ್ರೆಸ್ ಇನ್ ದ ವೈರ್. ದೇರ್ಫೋರ್ ಸ್ಟ್ರೆಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು, ಇಲ್ಲಿ ರೂಟ್ ಇದೆ ವ್ಯಾಲ್ಯೂ, ಅವಾಗ ಏನಾಗುತ್ತದು 10 to the power of 11. ರೂಟ್ ಈ ಕಡೆ ಮಲ್ಟಿಪ್ಲೈ ಆದಾಗ ರೂಟ್ ಇಂಟು ರೂಟ್, therefore that is 10 to the power of 4. Therefore 11 minus 4, that is 10 to the power of 7 Newton meter square. Stress in that wire is 10 to the power of 7 Newton per meter square. Option A is the right answer for this question. That is 1 into 10 to the power of 7 Newton per meter square is the stress in this wire. The next question is, which of the following statement is correct for stationary waves? Which of the following statement is correct for stationary waves ಅಂತ ಹೇಳ್ತೀನಿ. Which of the following statement is correct for stationary waves? Stationary waves ಗೆ ಯಾವುದು ವ್ಯಾಲ್ಯೂ ಕರೆಕ್ಟ್ ಆಗಿದೆ? Which of the following statement is correct for stationary waves? Here option A is stationary waves ಅಂತ ಯಾವುದು ಕರಿತೀವಿ ನಾವು? Stationary waves, they are also called standing waves ಅಂತ ಕರಿತೀವಿ. Stationary waves, they are also called standing waves ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಆಪ್ಷನ್ ಎ ದಲ್ಲಿ ಬರ್ತಕ್ಕಂಥದ್ದು nodes and antinodes are formed in case of stationary transverse wave only. Stationary transverse wave ಅಂತೂ ವರ್ಡ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಕ್ಕೆ ಬರಲ್ಲ ಇಲ್ಲಿ. This is wrong. Then in case of longitudinal stationary wave, compressions and rarefactions are obtained in place of nodes and antinodes. No, in case this is also wrong. In case of longitudinal waves, compression and rarefaction form ಆಗುತ್ತೆ. Nodes and antinodes possibility ಇಲ್ಲ. Suppose two plane waves, one longitudinal and another transverse wave. This is right. When the progressive wave is formed or stationary wave is formed, here two waves are collide with each other or combined with each other, then the stationary wave is formed. Two plane waves, one is longitudinal and the another one is transverse, is having the same frequency, having the same amplitude, or they are traveling in a medium in the opposite direction with the same speed. By superposition of these two waves, stationary waves cannot be obtained. And option D, none of the above. Here, which of the following statement is correct for the stationary wave? Option C is the right answer for this question. Then the next question is, that is, a transverse wave is represented by the equation. Transverse wave is represented by the equation. The transverse wave is represented by the equation, that is y is equal to y naught sine 2 phi divided by lambda into Vt minus x. Y equal to y naught sine 2 phi by lambda. Y equal to y naught sine 2 phi by lambda into Vt minus x. For what value of lambda is the maximum particle velocity equal to 2 times the wave velocity? 2 times the wave velocity. ಇದನ್ನ differentiation ಮಾಡಬೇಕು. Then only you get the answer. A transverse wave is represented by the equation. ಇಲ್ಲೊಂದು ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ equation, this is transverse wave equation. For what value of lambda? ಯಾವ ವ್ಯಾಲ್ಯೂವನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ ನಾವು ಇಲ್ಲಿ? lambda. For what value of lambda is the maximum particle velocity? It is equal to 2 times the wave velocity. ಯಾವಾಗ ಇದು 2 times the wave velocity ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿರುತ್ತೆ? Here particle velocity displacement ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ ವ್ಯಾಲ್ಯೂ ಅವರು. ಹೌದಾ? How to find the velocity from using displacement equation? The rate of change of displacement is called velocity, dy divided by dt. When you differentiate this equation, you get y naught into sine 2 phi by lambda ಇದೆ, 2 phi divided by lambda, 2 phi by lambda into phi cos 2 phi by lambda, phi cos 2 phi by lambda into Vt minus x. Vt minus x. But for maximum particle velocity, for maximum particle velocity, for maximum particle velocity, how to find the maximum particle velocity here? For maximum particle velocity, you know, okay, you add term y naught into 2 phi into v divided by lambda. Ist equation ಇತ್ತು ಅಂದ್ರೆ ನಾವು ಈಸಿಯಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. For maximum particle velocity, y naught equal to 2 phi into v divided by lambda. But you know the formula. Wave velocity is equal to wave velocity. Wave velocity, it is mathematically denoted by the symbol v. Wave velocity is equal to v. Therefore, this equation y naught into 2 phi into v divided by lambda. Y naught into 2 phi into v divided by lambda. This is equal to 2v. y naught into 2 phi into phi divided by lambda equal to 2 phi. Lambda equal to 2 phi. Here 2 phi and 2 phi get cancel. We get lambda is equal to phi into y naught. Lambda is equal to phi into y naught. Option D is the right answer for this question. Lambda is equal to phi into y naught. Option D is the right answer for this question. Now, the next question, that is the wave disturbance in a medium. The wave disturbance in a medium, it is described by, wave disturbance in a medium is described by y equal to x comma t, 0.02 cos, this is amplitude, this is omega, cos omega t, plus 5, this is phase angle, into cos 10 5x, where x and y are in meter and t is in second. X and y are in meters and t it is in second. Which of the following is correct? Which of the following is correct? ನಿಮಗೆ ಇಲ್ಲಿ phase angle and phase difference ಅನ್ನು find out ಮಾಡಕ್ಕೆ ಬರಬೇಕು. Here this equation, it is in the form of y equal to x comma t equal to a cos omega t plus 5 by 2 into cos kx. Y equal to x comma t equal to a cos omega t plus 5 by 2 into cos kx. This equation, ಇಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂಥ equation ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ, ಹೌದಾ? ಬಟ್ if kx is equal to 5 by 2, kx is equal to 5 by 2, ಇಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂಥ equation kx is equal to 5 by 2. In that conditions, nodes are occurs. In that conditions, nodes are occurs. Therefore, we get 10 phi x is equal to, ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ? 10 phi x is equal to 5 divided by 2. 10 phi x is equal to 5 divided by 2. Therefore, x equal to 0.05 meter. 10 phi x, ಇಲ್ಲಿರ್ತಕ್ಕಂಥದ್ದು 10 phi x. kx is equal to 5 by 2 ಆಯಿತು ಅಂತಂದರೆ 10 phi x equal to 5 by 2, 5 phi get cancel, x equal to 0.05 meter. If kx is equal to, here, if kx is equal to 5, kx equal to 5, 180 degree. If kx equal to 5, here it is occurred in antinode. Kx is equal to 5, antinode occurs. Antinode occurs means that is 10 phi x is equal to 5. Here 5 and 5 get cancelled. Therefore, x is equal to 0.1 meter. X equal to 1 by 10 agata. X equal to value ಏನಿತ್ತು 0.1 meter. 0.05 and 0.1 meter. But here also the speed of the wave is, how to find the speed of the wave? From using omega divided by k. This is free speed of the wave, that is 55 divided by 10 5. 55 divided by 10 5. You get the answer 5 meter per second. 5 meter per second. This is the speed of the wave. Option C is the right answer for this question. C is the right answer for this question. Omega value ಕೊಟ್ಟಿರತಕ್ಕಂಥದ್ದು ಎಷ್ಟಿದೆ ಇಲ್ಲಿ 50, okay, divided by k. K value ಎಷ್ಟಿದೆ 10. 5 5 ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, 0 0 ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, ಉಳಿತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? ಓನ್ಲಿ 5 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಈಸಿಯಾಗಿ ನೀವು ಮಾಡ್ಬೋದು, ಹೌದಾ, ವಿಥೌಟ್ ಎನಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್, ಡೈರೆಕ್ಟಾಗಿ, ಹೌದಾ. ವಿ ಈಕ್ವಲ್ ಟು ಒಮ್ಮೆ ಬೈ ಕೆ ಮಾಡಿಬಿಟ್ರಿ ಅಂತಂದ್ರೆ 50 by 10 ಬರುತ್ತೆ. ಬಟ್ ಅದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ಮಾತ್ರ ಈಸಿಲಿ ಯು ಗೆಟ್ ದ ಆನ್ಸರ್. ಆಪ್ಷನ್ ಸಿ ಈಸ್ ದ ರೈಟ್ ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಕ್ವಶನ್. ದೆನ್ two ends of a stretched wire of length L are fixed at x equal to 0 and x equal to L. In one experiment, the displacement of the wire is, that is y1 is equal to 2a into sine 5x divided by L into sine omega into t, and the energy is E1. And in another experiment, that is y2 equal to a sine 2 phi x divided by L into sine 2 omega t and energy E2. Y1 equal to 2a sine phi x divided by L into sine omega t and E1, and y2 equal to a sine 2 phi x divided by L into sine 2 omega 2. These are the displacement of the wires, the two ends of a stretched wire if the length L is fixed at x equal to 0 and x equal to L. And energy E2. What is the ratio? ಎರಡರ ಮಧ್ಯೆ ಇರತಕ್ಕಂತ ratio ವ್ಯಾಲ್ಯೂವನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ. But you know the formula. The energy of the vibration of the particle E is directly proportional to omega square and a square. Therefore, for y1, E1 is directly proportional to omega square and amplitude is 2 times of its amplitude. Therefore, we get E1 is directly proportional to 4 into a square into omega square, and y2, here energy E2 is directly proportional to 2 omega square into a square. Hence, E2 is directly proportional to 4, the square of its amplitude into omega square. Therefore, E2 is equal to E1. E2 is equal to E1. Option A is the right answer for this question. A is the right answer for this question. And the next question is, the mathematical form of 3 traveling waves are given by. Traveling wave, this is the second traveling wave, and this is the third traveling wave. The mathematical form of 3 traveling waves. Y1 equal to 2 sine 3x minus 60, y2 equal to 3 sine 4x minus 12t, and y3 is equal to 4 sine 5x minus 11t. These are the 3 mathematical form of the traveling waves. Along these waves, ಇಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂಥ ವೇವ್ ಅಲ್ಲಿ ಏನು ಡಿಫರೆನ್ಸ್ ಇದೆ ಮೂರರಲ್ಲಿ? ಆಪ್ಷನ್ ಎ, ವೇವ್ 1 has the greatest wave speed and greatest maximum transverse string speed, and here y1 equal to a sine omega. This is amplitude and this is angular frequency. Option B, wave 1 has the greatest wave speed. How to find the wave speed? Wave speed V is equal to omega divided by k. Omega divided by k. Wave 1 has the greatest wave speed and wave 1 has the greatest maximum transverse string speed. Option C, wave 3 has the greatest wave speed and wave 1 has the greatest maximum transverse string speed. Option D, wave 2 has the greatest wave speed and wave 3 has the greatest maximum transverse string speed. Here, for the wave, it is in the form of y equal to a sine kx minus omega into t. The wave speed is t is equal to omega divided by k, and the maximum transverse string speed is that is mathematically denoted by the symbol a into omega. P equal to omega by k, and the maximum transverse string speed is that is a into omega. ಇವು ಎರಡೂ ಫಾರ್ಮುಲಾವನ್ನು ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿ ನೋಡಿದಾಗ ನಮಗೆ ಇರತಕ್ಕಂಥ ಆನ್ಸರ್ ಏನಾಗುತ್ತೆ? ಆಪ್ಷನ್ ಡಿ is the right. Wave 2 has the greatest wave speed and wave 3 has the greatest maximum transverse string speed. Option D is the right answer for this question. Then the next question, here this diagram, it indicates the 3 progressive wave A, progressive wave B and progressive wave C. This figure, it shows 3 progressive waves A, B and C. What can be concluded from the figure that with respect to wave A? Question enu, what can be concluded from the figure with respect to the wave A? ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಎ ಪಾಯಿಂಟ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಏನನ್ನು ನಾವು ಕನ್ಕ್ಲೂಷನ್ ಮಾಡಬಹುದು? ಆಪ್ಷನ್ ಎ, ದ ವೇವ್ ಸಿ ಈಸ್ ಅಹೆಡ್ ಬೈ ಫೇಸ್ ಆಫ್ ಆಂಗಲ್ 5/2 and wave B lags behind by phase angle 5/2. No, this is wrong answer. And option B, the wave c is lag. The wave c is lag. Wave c is lag ಅಂದಾಗ wave c is lag. lag ಅಂತಂದ್ರೆ ಏನು? ಹೌದಾ? ಅಹೆಡ್ ಆ್ಯಂಡ್ ಲ್ಯಾಗ್ ಈ ರೀತಿ ಎರಡು ವರ್ಡ್ ಅದಾವೆ. ಇದನ್ನ ನೀವು ಅಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟಿಂಗ್ ಟಾಪಿಕಲ್ಲಿ ಕಲಿತೀರಿ. ಲ್ಯಾಗ್ ಬಿಹೈಂಡ್, ಅಹೆಡ್ ಬಿಹೈಂಡ್ ಪೈ ಬೈ 2 ಪೈ. ದ ವೇವ್ ಸಿ ಈಸ್ ಲ್ಯಾಗ್ ಬಿಹೈಂಡ್ ಬೈ ದ ಫೇಸ್ ಆಂಗಲ್ ಆಫ್ 5/2 and wave b is ahead by a phase angle of 5/2. This is right answer for this question. Then the next question is, a wave is represented by the equation. The wave is represented by the equation y equal to y naught sine into 10 5x minus 15 5 into t plus 5 divided by 3. This is the wave equation where x is in meter, t is in second. The equation represents the traveling wave. ಇದು ಯಾವ traveling wave ಅನ್ನು indicate ಮಾಡುತ್ತೆ? Here the negative sign with omega. The negative sign with omega, it is in the form of y equal to y naught sine omega into t. Sine omega into t minus kx plus 5. Minus kx plus 5. Here negative sign with omega, it indicates that wave propagating along the positive x-axis. Wave propagating along the positive x-axis, you get the equation omega t minus kx. Suppose it is propagating along the negative x-axis, then you get omega t plus kx. Therefore, here lambda is equal to 2 pi divided by k. Lambda equal to 2 pi by k. 2 pi divided by k. K is equal to value estide 10 into 5. You can write this equation kx minus omega into t. Kx minus omega into t. 2 pi divided by 10 pi. 2 pi divided by 10 pi. 2 divided by 5. 10 ಮಾಡಿದಾಗ value ಎಷ್ಟು ಬರುತ್ತೆ? 0.2 meter. 2 divided by 10, 0.2 meter. But the wave speed v is equal to omega divided by k. V equal to omega divided by k. Omega is equal to value ಏನಾಗುತ್ತೆ? 15 phi divided by 10 phi. 15 phi divided by 10 phi. Again 5 phi value get cancelled. We get only 1.5 meter per second. 0.2 meter and 1.5. 0.2 meter and 1.5. Hence, in the positive direction with the velocity 1.5 meter per second with the wavelength of 0.2 meter, it is the right answer for this question along the positive direction, not negative direction. Okay, then the next question is the equation for a transverse wave. The equations for a transverse wave along the positive x-axis, along the positive x-axis with amplitude 0.2 meter, velocity v equal to 360 meter per second, and wavelength lambda equal to 60 meter. You know the formula: wave velocity, wave frequency and wavelength. V is equal to f into lambda, or V is equal to n into lambda, and frequency n equal to V divided by lambda. The equation of a transverse wave traveling along the positive x-axis with the amplitude 0.2 meter, velocity that is 360 divided by wavelength 60. 360 divided by 60 value ಏನಾಗುತ್ತೆ? 0 cancel. 6 into 6 36. Therefore frequency is 6 hertz. And ಇಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂಥ ಆಂಪ್ಲಿಟ್ಯೂಡ್ a is equal to value ಎಷ್ಟಿದೆ? 0.2 meter. a equal to 0.2 meter. ಇವು ಎರಡು ವ್ಯಾಲ್ಯೂವನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಫಾರ್ ದ ವೇವ್ ಟ್ರಾವೆಲಿಂಗ್ ಅಲಾಂಗ್ ದ ಪಾಸಿಟಿವ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್, ಟ್ರಾವೆಲಿಂಗ್ ಅಲಾಂಗ್ ದ ಪಾಸಿಟಿವ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ y equal to a sin omega t minus kx in ಜನರಲ್ ಫಾರ್ಮುಲಾ ಬರೀಬೋದು ನಾವು. ಇದನ್ನು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿ ಬರೆದಾಗ y is equal to a sin, y equal to a sin omega equal to ಏನಾಗುತ್ತೆ? 2 phi by t. 1 by t ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತದು? ಫ್ರೀಕ್ವೆನ್ಸಿ 2 phi n into t minus here 2 phi x equal to value ಏನಾಗುತ್ತೆ? x divided by lambda. 2 phi x divided by lambda. Therefore y is equal to a sin, take the common value outside, that is 2 phi n into t minus x divided by lambda. Now you substitute these two values in this equation. We get y equal to amplitude is that is 0.2 sine 25 into n equal to frequency ಎಷ್ಟಿದೆ 6t minus x divided by lambda equal to 60. We get this answer y equal to 0.2 sine 25 60 minus x divided by 60. Option ಯಾವುದಾಗತ್ತೆ ನೋಡ್ರಿ question number 10 ಗೆ option A is the right answer for this question. This is very important problems. ಈ ರೀತಿ ಇರತಕ್ಕಂಥ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಿಮಗೆ ರಿಪೀಟೆಡ್ಲಿ ಕೇಳಿರ್ತಾರಂತಹ ಕ್ವಶನ್ ಇದೆ. ದಿಸ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಅಂಡ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಈಸ್ two points are located at a distance of 10 meter and 15 meter from the source of oscillation. The period of oscillation is 0.05 second and the velocity of the wave is 300 meter per second. What is the phase difference between the oscillations of 2 points? Phase difference between the oscillations of the 2 points. Here, the phase difference between the oscillations of the 2 points, the option B. Here, do kuda same question idanga avagle enitadu. Try to solve yourself. Option B is the right answer for this